Okay, so that concludes our crash course into NumPy. So next we're going to do Pandas. So Pandas is this software library that is used for data manipulation and analysis and offers data structures and operations for manipulating numerical tables and time series, especially. Time series are really handy, especially in the natural sciences and physical sciences. So there's a number of features with Pandas that are really handy. There's a data frame for manipulating data with integrated indexing. There are tools for reading and writing data between data structures and different file formats, so it supports not just comma-separated values and tab-separated values. It also supports Excel, so you can read and write Excel files, which is really handy. You can align and integrate data and handle missing data, reshape and pivot data sets. You can slice based on labels. You can use fancy indexes and masks and all the things we've seen to subset large data sets. You can insert and delete columns or rows. You can group by certain things and do this sort of split, apply, combine operations on large data sets. You can merge and join data sets in sophisticated ways. It supports hierarchical indexes to work with higher dimensional data in a lower dimensional structure. And it also has really nice time series functionality. So dealing with date ranges or discrete dates, you can move between time zones and shift dates, and it really handles a lot of date and time functions really well. And it's optimized for performance, so it's pretty fast as far as these things go. So for the tutorial today, we need to download a file. So we're going to click on this link here. I think, well, let's see what happens if I just click on it without, yeah, okay. So it'll just open up a new tab, and this is linked to our data directory in the GitHub page. So we can just copy this link, and since we're already in the Jupyter Notebook, we can either open up a new tab, or we can just go back to our Home tab and click on New Terminal. And then we can do curl-o, or if you're using a Linux environment, you can use wget. Paste that URL, all in quotes, hit enter, and it'll download that data. So this is just a very small CSV file. It's 67 lines of physical data from the Scripps peer from 2015. The other thing we need to do is make sure we have Pandas installed, which I think everyone here does, but I think we don't have Matplotlib installed. So you can go back to your terminal here and type. You can see we're in the environment, so you always want to check which environment you're in before you start installing packages. So we're in the Python 3 environment. So you can do conda install matplotlib and hit enter. This might take a few seconds depending on your internet connection and the server on the other side. Now for me, I've already installed it, so it's just going to say all packages already installed, but if not, it'll say, do you want to install? Just type Y, hit enter, and it'll install. Everybody, did that work for everybody? Yeah, you can do, I think it's conda, update conda. So once you do that, you can go back to the notebook. And so now we can import our modules. So this command is gonna say import pandas as PD. So we've seen that before. This is just a shortcut. We don't have to type pandas every time we want to use pandas. We can just type PD. And this is a standard abbreviation that people use. So you'll see this other places. And we're going to import Matplotlib, but not the whole Matplotlib. We're just going to import pyplot as PLT. And then we're going to use this magic command, which is specific for the notebook. You don't need this in other environments because what this will do is this will force the notebook to any kind of Matplotlib plots that are generated, any figures that are generated will be rendered right in your notebook. If you don't do this, they won't show up. So we're going to execute that, and if you have everything installed, it should not generate any errors. So we're going to read the data from a CSV. So we're going to use the pandas command. So we're going to do pd.read CSV. So this is a special function that reads in a CSV file, and the first argument is just the name of the file. Here we're going to just enter the name of that file. It should be in our current working directory, but if it wasn't, we could provide the full path. Instead of here, we're just showing the relative path. You can also, and I recommend this if you're doing large programs, you can define your paths up at the beginning of your program. Because remember, if you wanted to convert this to a Python script, you'd want to have the ability to make an argument of that path instead of just hard coding it into your code. But here we can just list it here. And we're going to say index column equals none, so we're not going to specify which is the index column, and we're going to say header equals 0, so that line 0. In fact, let's go back and look at this file. So we can go back to our terminal and type head scripts peer, and we tab complete. And you can see that it's this text file that's CSV, so comma separated. So we have the date and time, and then chlorophyll, pressure, salinity, and temperature in a CSV file. So we're going to say, and so the header is the first line, which is line 0, and we're not going to specify an index column. So when we do that, we're importing this file into a data frame. So if we then type data1 period head, this is now a pandas data frame. We're just seeing the first 5 or 6 rows of this data frame. So we have the header and then all the values, and then the index is just numerically indexed from 0. That's the standard way if you don't provide an index. However, we can change this command. We're going to call this data frame data2. So it's going to be the exact same command, except now we're going to specify the index column is column 0. So that's this column here. We're going to say I want the index to be the date time, not to be just some arbitrary thing. So we see now that the index column is now this date. It's called date, and it's this date time object. Now there's advantages and disadvantages to doing it one way or the other, as we'll see. There's this describe function, which is really handy. We'll come across this again, but this is one of these nice features of pandas that is available. And what it does is it takes all of the data that we have and gives us the count, which is the number of values, the mean, standard deviation, and then these quartiles. And so it's just a really nice way to get a snapshot of your data set without having to do too much work. So when we are indexing in Pandas, it's in some ways it's similar to what we've seen before. There's an index function called iloc, which works on index position, so it takes integers. But there's also an indexing function called loc, which works on labels in the index. So if we're looking at this data 2, we can specify the index location, or iloc 0 will give us the values for row 0. If we want, so this iloc gives us is used to index rows. Rows have either rows always have a label index, which is either in this case it's this date, but it could also be this number. But these have a text value that you can use to index, but you can also use the position. So even if you have a long string like this, which is your index for that row, you can just say this is 2, 0, 1, 2. So this is row 2. If you want to pull out the column, you can use positional indexing, but you can also just use the name of the column, which is ideal. So here, like say we want the column chlorophyll, it's chlorophyll space UG divided by capital L in parentheses. So, or temperature here. So this would give us the column of temperature. And then we're going to do, we're just going to get the first 10 rows. So we're going to do this whole thing, and then dot head, and head takes an argument. In this case, we're going to say we want 10. So we get the first 10 rows. The other thing that you'll see is that at the bottom of when we slice or index this data frame, we're getting, in this case we said we wanted row 0, so it's gonna, at the bottom it's going to give us the index name for that row and also the data type for that row, if there is sort of a consistent data type. There might not be. For the column there will be a consistent data type, so it's going to remind us that the column name is temperature parentheses capital C, and the data type is float, or float 64. So it's a 64-bit float data type. If there is no index column, we can still use this positional indexing. And we can actually use the label-based indexing too, because it turns out that 0 is also the name of the row. It's not just the position; it's the name of the row, because that's how we entered it. Okay, I don't need this. There used to be a third indexing called IX, which would either could work with both depending on what you provided, but they've deprecated that. So these are our two main options. And again, we can use for a column. We don't need any kind of we don't necessarily need any kind of indexing function. We can just provide the name of the column, and then here I don't want all values, so I'm just gonna use this head command to only get the first 5 values.
The first row.
Yep.
Converted from all to strings.
Yes. Yes, correct. So what's happening is now that all the data in this CSV file is floating point values, except for the date time, right? That's a string that can be interpreted as a date time, but fundamentally, if it's not, if we don't tell it, it will just interpret it as a string. So what happens is, if the whole row, if we consider the whole row as a it effectively turns into a pandas series. A series is like an array, like a one-dimensional array in pandas. So a series is typically, we think of it as a column, and columns have to have the same data type, but rows do not, right? Because you could have a row of text, you can have a column of text, you can have another column of floats, you can have another column of integers. But when you take a row, you've now got all these mixed types. So unless they're all the same type, up above we saw that when we took the row, these are all floats. So it's that row is a float data type. But once we throw in, now we've now made it so the index is not the date. The index is just this integer. Now date is now a column of data. And so when we consider that whole row, it now has to consider everything as an object or a string. So this can have some consequences, but typically it doesn't. It's not changing how it's stored internally. It's just this is just a slice. So this particular slice that it's spitting out is now an object, but the underlying data structure is not changed. So we can also use, so we can get that date column by using the label, but we can use positional indexing this way too. So this can be really handy. Typically, it's good to give your columns, especially if you're using Python, to give your columns like clear, descriptive header names that are easily amenable with Python. So this would be only alphanumerics. So letters, numbers, and underscores, and preferably all lowercase. The advantage of that is that you can do things like this. So we can data1.date, and it still works. So we don't need the brackets. This is just saves time. Whereas we wouldn't be able to do that with, what was it like? All right. So this would be how we showed temperature, but if we wanted to do something like, yeah, like that won't work because there's all these non-valid characters for a regular command. They're fine in quotes, right, but not otherwise. So we'll see in a minute that way we can convert those to something more usable. So yeah, so you can use this positional indexing to get, in this case, all of column 0, and then we'll just get the first 5 values just for succinctness. If we do leave out this head command, it'll print everything, but depending on how we have our notebook set up, it'll remove some of the lines, and then we can also click on this little sidebar to shrink it. We can even make it go totally away. But let's just do this, and we don't have to worry about it. Now we can we'll see more about date timestamps later in the course, but I can just show you an example. So Pandas has this function toDateTime, and we're going to take this row, this date time row that we just were talking about here, and we're going to apply that function. Let's do this, actually. So this is a series, but it has this special, now that we've converted it to a datetime object, it has this special data type, which is called datetime64ns. Basically, it's a datetime object. So you can see that it basically took this series of of strings. So these were just strings. It doesn't know that they're dates. It's just saying 11, 10, 15, and then a time. But if we convert that to a date time object, then it recognizes that it's a year, month, day. It gives it hours, minutes, and seconds. In this case, there's no seconds provided, so it's just zeros. And this has a special data type.
Could you have them in the opposite order? Like if you had your time and then your date in your CSV, would it recognize some of the time?
So yeah, good question. So the Pandas datetime or toDateTime function, sometimes it can handle multiple formats, but I'm not sure how it works with time followed by date. Certainly it will, if you give it a list of dates that could be interpreted, let's say it's like today, it's like February 8th, right? If you write 2/8, is that February 8th or is that August 2nd?
Yeah.
So if it's only dates in that date, I'm not sure what the default is, but if you give it enough dates that it can figure out which is which, it will make the right choice.
Is there any way to specify? Because in Matlab you can just tell what the format is.
Yes, there is, I believe, but I don't recall off the top of my head, and we have like a whole lesson on it later in the course. So.
When you
Yeah.
think time, like if I just type time, enter,
Mm-hmm.
it gives me most of it, but it cuts out a few rows in the middle.
Yep.
Is there a way to force it just to do it?
Yeah, so that has to do with the Pandas settings in your notebook. So you can change the defaults to, so here it's showing you 30, it's basically showing you 60 lines. There's a way to change that, and I can show you that later. I don't recall the syntax right off the top of my head.